Hey everyone, welcome to the Rutgers RPL video tutorial series on OpenRocket. My name is Aryanna Arcilla and I am Launch Logistics Manager here at Rutgers RPL. This series will explain to you the process of designing your L1 rocket. If you would like to see all of the videos in this series, make sure you head over to our YouTube channel and click on the OpenRocket tutorials playlist. In this video, I will be explaining the basics and parts of a rocket. It's good to refer back to this video should you need to as you are designing. I'll also explain how the rocket will function and how the parts will work together. First, let's go over directional terms. The top of the rocket is referred to as forward. The bottom of the rocket is referred to as aft. Remember, these are directional terms. So for example, if I say the forward end of the fins, I mean up here. And if I say the aft end of the fins, I mean down here. The rocket has a motor and a parachute inside of it. When your rocket is launched, it will eventually reach Apogee, the highest point it can before falling back to the ground. The time when Apogee is reached can be predicted by designing your rocket in OpenRocket, then simulating it. Once you are finished designing your rocket, you can simulate it and figure out how many seconds it will take to reach Apogee. At that point in time is when you want your parachute to release. This is why it's important that your rocket is designed without any big mistakes. If you simulate it incorrectly enough, your parachute could launch too early or too late. Keep in mind that your simulation data will eventually be given to the National Association of Rocketry, who will be giving you your L1 certification as proof that your design works. Right here, I have my rocket, Snoop Dogg. On the top is the nose cone of the rocket. This nose cone is made from fiberglass, which is something that would be too expensive for everyone who is designing a rocket to buy. For this reason, as of now, Rutgers RPL only has 2 nose cones. We share these nose cones and will switch them from rocket to rocket on launch day. That means that when I take this nose cone off, this bottom part of the rocket is all that you will be building. You can see that the very top of the nose cone is missing. What will go up here is something called the nose cone, which is just a smaller nose cone made out of metal. Notice how within the nose cone is a metal plate and some rods. On this metal plate and rod will be any electronics, if necessary, that will be put in your L1. Sometimes, but not all the time, we use electronics to ignite rockets. Sometimes things like a camera, altitude sensor, pressure sensor, and other things are put in here for the purposes of getting data for testing reasons. This is the body tube. It's made out of cardboard. You can see that I definitely had fun decorating this. Once you are finished designing your rocket, you will be able to decorate your body tube any way you would like, either with paint or with stickers. Within the body tube will be your motor tube, a parachute, a bulkhead, and centering rings. You'll also have additional hardware such as clips and links to hold these things together. Most of these parts, including your fins, are held together with a mix of epoxies. As long as you put a good amount on, your rocket will be sturdy enough to withstand launches. Right now, there are certain parts that are epoxied inside my rocket, but I have them here. This small cardboard tube is called the motor tube. These 2 discs made from MDF are called centering rings. When placed inside the rocket, this makes sure that the motor doesn't move. Notice how the slits in the centering ring are only facing inside. This is because between the 2 centering rings is where your fins will go, and they will be slid and epoxied inside the slits. When I turn the rocket on its side, you can see the bottom of the aft centering ring and the motor tube. This hole is where your motor will go. This wood disc is called the bulkhead. On this link, you will clip your parachute to your rocket. Once the parachute is set off, your nose cone and your body tube will be in 2 pieces. However, these 2 pieces are held together by strings on the parachute, as long as they are attached to both the nose cone and the body tube. Notice how the forward edge is angled so that the air flows through it nicely. You can also see that there is a very small overhang. There's just a little space between the table and the centering ring. In the fins video tutorial, I will warn you that having too big of an overhang is risky. If the rocket were to land vertically, this means all the force from the rocket hitting the ground is going to the fins. A little bit of an overhang isn't too big of a deal. But if these fins had much more of an overhang, you risk breaking the fins off your rocket. The biggest risk you could possibly have is if your fins have pointy ends and a big overhang. For this small overhang, the force at least gets distributed along the bottom of these lines. For rockets with pointy fins, the force gets distributed only to that one point on the fin, and can definitely break off. The parameters for making your fin are not as set in stone, However, you will see later on that there are certain things you can do to improve the chances of a successful launch. So this, what I'm holding right here, is the motor casing. Up here goes the black powder, which will eventually set off and launch your parachute. And over here, when your rocket is launched, this is where all the thrust will come out of, this bottom part. If I unscrew the top here, in here will go your propellant grains, which are the solid fuel that will make your rocket actually go. There's also additional parts that will go in here, but we're not going to go over that right now, and we'll go over it in the motor loading part of the tutorial. This motor before launch goes in this hole right here. I'm not going to put it in right now because I'm afraid if I do, I'll start to wear down the cardboard because it does fit very snug in there. And if I start doing it too many times, then there's definitely a chance that the motor could slip out. So you'll see it when you actually start to launch.
Subscribe to our channel to keep up with all our latest content and launches. For more of Rutgers RPL, check out our social media links, as well as our website at www.rutgersrpl.com. Join us today.